Hey everyone, and welcome. Today, we're going to tackle absolute value equations. Now, I know they can look a little intimidating at first, but once you learn the secret, you'll see they're actually pretty straightforward. So let's dive right in and get this down pat.
Okay, to get us started, let's kick things off with a little warm-up question. Just picture a number line in your head. If there's a number that is exactly 5 steps away from 0, where could that number be? Just chew on that for a second.
If you were thinking of two different spots, you are absolutely correct. The number could be positive 5, of course, but it could also be negative 5, right? Both of them are exactly 5 units away from 0. And that right there, that idea of two possibilities is the key to everything we're about to do today.
So, what we were just talking about, that is the core concept of absolute value. It's simply a number's distance from 0. And think about it, you can't walk a negative distance, right? So the absolute value of any number is always positive.
So how does this all translate into algebra? Well, we use this really powerful technique that I like to call the split maneuver. It's the one key move you need to know. You take one absolute value equation and you split it into two much simpler ones, a positive case and a negative case. Okay, so enough talk, right? Let's actually see how this whole maneuver works with a real equation. This is where the magic really happens and those absolute value bars just disappear. Here's our first one. The absolute value of x plus 2 equals 6. Now the first thing you should notice is how that absolute value part is all by itself on one side of the equation. That is our green light. That means we are ready to perform the split maneuver. So here's the most important part. We're going to take this one equation and split it into two separate paths, our positive case and our negative case. And pay close attention, because the second we do this split, poof, those absolute value bars are gone for good. Yeah, this slide lays it out perfectly. For case 1, our positive case, we literally just drop the bars and write x plus 2 equals 6. Simple. Now look at case 2, the negative case. The part inside, the x plus 2, stays exactly the same. We don't touch it, but the answer on the other side flips to negative. X plus 2 equals negative 6. That's the whole move. All right, now it's just simple algebra. For the positive case, we subtract 2 from both sides, and we get x equals 4. For the negative case, we subtract 2, and we get x equals negative 8. 2 equations, 2 solutions. That's it.
Okay, that was pretty clean. But what happens if the equation's a little messier? And this, my friends, leads us to what is probably the single most important rule you need to remember. You must isolate the absolute value before you even think about splitting.
Let's check this one out. 2 times the absolute value of 3x minus 4 equals 14. See all that extra stuff hanging around? The absolute value of 3x isn't alone. That means our hands are tied. We can't do the split just yet. We've got to clear out all that other stuff first. So the game plan is always the same. Step 1. Use your regular algebra skills to get those absolute value bars all by themselves. Step 2. Only then can you do the split maneuver. And step 3. Solve both of your new, easier cases. Just burn it into your brain. Isolate, then split. So let's apply that to our problem. First, we'll add 4 to both sides. That gives us 2 times the absolute value of 3x equals 18. Then we need to get rid of that 2, so we divide both sides by 2. And now, look at that. We have the absolute value of 3x equals 9. It's isolated, it's clean, and it's ready for the split. We just create our two cases, 3x equals 9 and 3x equals negative 9. And that gives us our two solutions, x equals 3 and x equals negative 3. Okay, let's switch gears and talk about a few common traps. You know, the little things that can trip people up. Knowing what not to do is honestly just as important as knowing what to do. So let's make sure you don't fall for these.
Take a good look at this one. The absolute value of x minus 5 equals negative 3. Now, the bars are isolated, so your first instinct might be to just jump right in and split it. But hold on a second.
Let's just pause and really think about this. Remember what absolute value actually means. It's distance from 0. So this equation is literally asking us what number has a distance of negative 3. Does that even make sense? Can a distance be negative?
No way. It's impossible. An absolute value can never, ever equal a negative number. So the second you see that, an isolated absolute value set equal to a negative, you can just stop right there. You found a trick question. The answer is simply no solution.
And here's the other big pitfall I see all the time. When you make that second case, the negative one, please remember, whatever is inside those bars, don't touch it. The expression x minus 2 stays exactly the same. The only thing that changes is the number on the other side of the equal sign. That's the part that flips to negative.
So you're probably thinking, okay, this is neat, but when am I ever actually going to use this? Well, absolute value is super important in any field that requires precision, like engineering or manufacturing. Let's check out a super practical example.
All right, picture this. You're in a factory that makes those tiny little computer chips. And according to the design, every chip is supposed to be exactly 5 millimeters wide. That's the perfect target size.
But, in the real world, nothing is ever perfect. So the quality control team says a chip is still good to go as long as its size is off by no more than 0.1 millimeters. This plus or minus wiggle room, that's called tolerance.
And this is exactly where our math comes into play. We can let the letter x represent the actual size of the chip we just made. So the difference between the actual size x and the target size 5 has to be 0.1. We can model this perfectly with the equation the absolute value of x minus 5 equals 0.1. And when we solve that using our split maneuver, what do we get? Our two answers. The minimum acceptable size, 4.9 millimeters, and the maximum, 5.1 millimeters.
All right, so let's quickly recap the big ideas from today. First up, remember that absolute value is really just about distance from zero. That means it's always positive and, usually, you're looking for two answers. Second, the golden rule. Isolate those bars before you split. And finally, always keep an eye out for that no solution trap when an absolute value equals a negative.
So there you have it. You now have the main technique for solving absolute value equations. But that kind of gets you thinking, right? We've figured out what happens when something is exactly a certain distance away. But what if you need to be less than that distance? Like staying within that tolerance range? Well, that's a whole new ballgame, and we'll explore that next time.